lessons I learned when I was studying here was that when you want to introduce a mathematical concept, you start with an application first, and then you teach the math. And as a Merrill College professor, interacting with the education people, I've learned that you start with something the students know, and then you go to the new stuff. And so if you think about how children grow up, their first curiosities are about what's going on in their world, and generally about animals and plants and insects. And so we kind of have a natural feel for biology. We're curious about it. So starting with something somebody knows, biological example, a simple one, but something that they know, and then going to the mathematics has been really great for me. One of the examples I use in pre-calculus when I'm teaching sine curves, which are just, up and down curves, is blood pressure. Because everybody's blood pressure, you get a high number and you get a low number when they take your blood pressure. But it's really a curve of pressure, and it's essentially a sine wave. So we talk about that. We start with a blood pressure measurement, and we say, how could we fit a curve to this data? It's regular, your heart beats every whatever seconds, and so what we do is we fit our sine waves to our blood pressure. And that's been really great because it gives students a reason for studying the sine wave instead of using the unit circle and the geometric approach, to use the graphing approach, the up and down, the cyclical approach. So that's one example. Okay. Well, there are so many, but one of the things about some of the things I did in my dissertation is you can take away a lot of the noise, and you can create a biological system that you have complete control over. So you can get at things that would be hard to get at in the lab. You can test out things that you couldn't test in nature because you would mess something up. In the computer, you can't really make a mess. So using mathematics that way is very important. Also, being able to quantify what you're looking at so that you have more of a sense of the scale of things, what's happening, how it's happening. Sometimes you can get at the why is it happening. So that's kind of how I think about it. Well, teaching at a liberal arts institution, I think about most disciplines as interdisciplinary. I think that most of my students are going to go out in the world and deal with issues where they're not dealing only with the biology. They're going to have to talk to a business person. They're going to have to talk to the economist, the sociologist, maybe a physicist, maybe another scientist, maybe a mathematician. So this way, they all have a common language to talk about these things with. If they can quantify things with mathematics, if they understand the mathematics, there's a way of talking and measuring things that they can use to communicate with each other.